Hey everyone, I wanted to give you guys a quick recap video on your quizzes. That way you guys can be learning from your mistakes and get some feedback. So first off, let's go through quiz 1. Which of the following statements is false? Organic and inorganic compounds obey the same laws of nature. That's true. Organic chemistry involves the study of compounds containing carbon. That is true. The most common element found in organic compounds are carbon, hydrogen, nitrogen, oxygen. That is true. Organic compounds cannot be synthesized in the laboratory. That's false. Organic compounds can be synthesized. In fact, we talked about urea being the first one. A chemical has two pure samples, or a chemist has two pure samples, one of which she obtained from a natural source and one she synthesized in the lab. Which of the following properties can she use to determine which is the synthetic one? Well, the answer is none of these. Since a synthetic organic compound is identical to a natural organic compound, their solubilities, boiling points, formula weights are going to be the same. In which of the following classes of organic compound must there be at least two oxygen atoms? And we're given ester and acid, both or neither. So if we take a look, a carboxylic ester automatically has to have carbonyl carbon, then it has to have an oxygen bonded to something else. So there's your two. For a carboxylic acid, simplest one, well, I guess the simplest one could have an H on it, but it has to have an OH attached to the carbonyl carbon, the C double bond O. So you can see here that there needs to be at least two oxygens in our carboxylic acid and our carboxylic ester. So the answer there is both. Question 4. Which of the following is an example of a secondary amine? Well, a secondary amine is a nitrogen that's connected to a carbon that has two carbons on it. And all of these, you can see the nitrogen is on the end of the molecule. So it's just connected to one carbon. If we were representing a secondary amine using formulas, you would often see it something like that. So here you can see that the nitrogen is attached to the carbon, who's attached to two other carbons. But when you see CH3, CH2, CH2, NH2, it's on the side. So again, we'll put a little line and stick it off of another carbon if that's the case. This is the same one. That's the same. But if we had CH3, CH, CH3, and an NH2, or if this was a 2 and this kept going, anywhere in the middle, it's going to be secondary. Tertiary, it would be attached to a carbon with three carbons on it, so the carbon wouldn't have an H. We'd have like CH3, C, CH3, NH2, CH3, something like that. Tertiary. So in this one here, none of these, D, would be secondary amines. Question 5, what are the bond angles around the carbon atom bonded to the oxygen atom? And so the carbonyl carbon is what you're looking at there. With this question, you have to remember a little bit about your Vazquez, valence shell electron pair repulsion. So when you have a carbonyl carbon that has a double bond in it, it automatically makes three electron groups. There's the electron group going this way, the one going this way, and the one going this way. So these will spread out 120 degree angle from each other. So remember, for carbon, when it's all single bonds, 109.5 degrees. When it's three bonds, three electron groups, at least one double bond, then it's 120. And if there's a triple bond, then it's 180 degrees. So the answer here was C. My bad, B, 120. Compounds which contain a carbon-carbon double bond are classified as which of the following? This was an easy question for you guys. They're alkenes. Arenes do have double bonds, but they contain more than one. and they have to be conjugated, meaning they're staggered. Question 7. Which of the following represents the molecular formula for an unbranched alkane? This isn't a trick question. If we branch an alkane, it doesn't give it a different formula. If we include double bonds or add a functional group, then that changes, but branched or unbranched, they're the same. What the question here is asking you is, for an unbranched alkane, how many hydrogens and carbons should you have? Unbranched just means the straight chain. The formula here is 2n plus 2. So whatever number of carbons you have to have twice as many plus 2 hydrogens. So for A, 5 carbons, we should have 12 hydrogens. So no. B, 6 carbons, we should have 14 hydrogens. So no. C, 7 carbons, that should be 14 plus 2, 16 hydrogens. So incorrect formula. D, 8 carbons. So 8 times 2 is 16 plus 2 is 18. So that is the only formula here that matches what a formula should be. If you tried to draw any of those other ones, you'd be missing hydrogens and there wouldn't be double bonds and there'd be nothing else in there. You wouldn't know what to do with it. This kind of plays the same. What is the molecular formula of the following compound? So let me draw it for you so you can see. I don't remember what it looked like. It branches down. Okay. We get something like this. So what you do is you count all the angles and ends. 1, 2, 3, 4, 5, 6, 7, 8. So if there's 8 carbons, there should be 18 hydrogens. Oops, that was funny. Because times 2 plus 2. So if you look at the formula, there's only, so 3 of them have 8 as an option, but the number of hydrogens is wrong for B and C. So D is the only right answer, because the hydrogens are wrong. The formula, remember, 2n plus 2. Here you're just spotting what is correct and what's not correct. The sec-butyl group is obtained by doing which of the following? Removing a hydrogen atom from C2 of butane, removing a hydrogen atom from C1 of 2-methylpropane. The question here is, if I wanted to add sec-butyl to one of my molecules, what do I have to take off of a butyl or of a butane or a 2-methylpropane to do that? So I'll just show you. If I've got a long alkane here and I want a sec-butyl group, sec-butyl, remember, attaches right there. So it's a butyl group because it's got 1, 2, 3, 4 carbons, but it's attached at the secondary side where I'm attached here, so I have 1, 2 other carbons attached. So what would I do to make this group? Well, I would have a CH3, a CH2, a CH2, and a CH3. This is butane. I want to attach it right here, so I need to remove one of these hydrogens to make room, right? Carbon can't have all those bonds. It's got a hydrogen on it, and then it's attached to the rest of my molecule. So we had to lose one of those hydrogens. So this would be carbon number 2 of butane. So we can remove a hydrogen from carbon number 2 of butane. If you tried to remove a hydrogen atom from carbon 1 or carbon 2 of 2-methylpropane, that's going to give you a tert butyl. 2-methylpropane is already going to be arranged different. It's not a straight chain. That one has a tertiary carbon in it. But you would just try to do that. Now, removing a hydrogen atom from C1 of butane wouldn't give us sec-butyl. It would just give us butyl, the group butyl. Question 10. Which size of rings of carbon atoms are especially abundant in nature? Well, we talked about 5 and 6 carbon. 3 and 4 is too small. 4 is still too small. And 6 and 7 are just not the right numbers. It's 5 and 6 we see all the time in nature. Okay, so that's quiz 1. Let's take a look at quiz 2. Which of the following molecules has a linear structure, so 180-degree bond angles? The only one here would be an alkyne, And if we look at these, ethylene, benzene, acetylene, ethane. So it was a trick question. Although enes there are alkenes, ethane is not an alkene or an alkyne, and acetylene is the common name for ethyne. So that was the 180-degree angle there. A student wanted to use branch groups, isobutyl, secbutyl, tertbutyl, when naming alkenes, but was told not to. What is the correct IUPAC name for the compound the student calls isobutyl ethylene? So they don't want to use the common names butyl, iso, that kind of stuff. So ethylene, we know, is just a CC double bond. Now, isobutyl means that on this ethylene, I'm going to stick a secbutyl or an isobutyl. So I'm going to have to put a group here. Isobutyl means carbon, 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 carbon. There's my isobutyl. And okay, isobutyl ethylene. So how would we name this using the proper naming system? Well, we're going to name the longest chain. So 1, 2, 3, 4, and it doesn't matter which way we go here. We'll go 5. So this is some kind of pentane. Actually, it's some kind of pentene because it has a double bond. It is 1-pentene because the double bond takes place on the number 1 carbon. And then we have a branch on the number 5 when it looks like it's a branch on the number 4. And it looks like that is a methyl. Right? This branch on the number 4, 5 carbons long, a number 1 for our double bond. So 4-methyl, 1-pentene would be the proper name for what the student is calling isobutyl ethylene, or isobutyl ethene. Which of the following statements is true about the solubility of alkenes? All alkenes are soluble in water. Not true. None of them are. Long-chain alkenes are soluble, but short-chain alkenes are insoluble. If anything, it would be the opposite, but still, that's not true. Long chains are insoluble, and short chains are soluble. That's true for alcohols and other things that have polar functional groups, but not alkanes, alkenes, or alkynes. All alkenes are soluble in alkanes. Yes. So ethylene would be soluble in hexane, let's say. Number 4, which of the listed products will be formed in the following reaction? So let me draw that for you guys. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So we've got this guy here. Let's just remind you what this looks like. This is a carbon double bonded to a carbon who's got a carbon and then a CH3. I'm only going to show the carbon bonds that we need to see here. So again, these guys we don't need to see. And this one has an H. Okay, so we're going to break this bond in blue and actually just form 2 new bonds onto these 2 carbons. Now we're adding HCl. So we're going to add an H to one of those bonds and a Cl to the other bond. Now the rule here was Markovnikov addition. Hydrogens will go to other hydrogens, chlorine will go to the more substituted carbon. So it's clear here which carbon has more hydrogens on it. So we'll send the hydrogen there and we'll send the chlorine there. And so your structure now looks like so I guess it would be like that. There'd be a chlorine sticking out from that junction. So C and D are wrong because they've got 2 chlorines on there. We didn't add Cl2, we added HCl. A is wrong because it added the Cl to the other carbon. B is the one we want because it gets the chlorine on the carbon that had less hydrogens. Question 5. Which of the following is used as a monomer to prepare the polymer given below? So you can see the repeating portion in parentheses. right? So let me give you the CH2Br. So we've got CH double bond CH2. Actually, that's the actual molecule. What they were showing us was C, I believe, did this have an H2 on it? It must have had an H2. And this guy must have also had an H2 and then CHBr. So since this is the repeating part, in parentheses, that means that's where the double bond was, because now, right, we've got a whole bunch of these repeating parts. And so on. That's what the parentheses mean. So that's where the double bond was, because remember, the double bond that was here just opens up and grabs the next one, and then that double bond opens up and grabs the next one. So we'll just put the double bond back. If we put the double bond back, this is where it goes, right? And now we have to pick what this thing is called. Well, it's easy. Let's name it. 1, 2, 3. So this is propene, and we've got the double bond on the number 1, so it's 1 propene. But it isn't 1 bromo 1 propene. The bromine isn't also here and not part of the repeating unit in parentheses. So we know that that's far away from a double bond. That's on the number 3 carbon. So this looks like 3 bromo 1 propene. So let's go back and check what our options are. We've got 3 bromo propene. We've got 2 bromo propene. I guess with propene, we don't really have to say the number 1 because there's only one place to put a propene. Right, this is propane, so we can put the double bond there and call this the number 1. But we can put the double bond here and call this the number 1. Wherever we stick it, we're going to call that 1 propene. So the 1 is not important here. So that's why the 1's not showing. But they do have 2 bromo propene and 3 bromo propene. We know 3 bromo propene is better. Trans 1 bromo propene. So here they had the bromo and the double bond on the same carbon because it's got number 1 in front of the bromo. We know that's not the case either. So 3 bromo propene is the best answer there because it matches what we drew. Question 6. On what basis was the name aromatic originally given to compounds? Well, they had pleasant odors. Aromatic was considered to be pleasant. Which of the following is a correct IUPAC name? So hint, try drawing them. So here you just have to go through them and see what works. Let's try 6-bromo 4-chloro toluene. So toluene is a benzene. It said 6-bromo, so toluene, of course, has a CH3 on it. What did it say? 6-bromo 4-chloro. So 6-bromo is this. 4-chloro is this. I think we would just name the other way. We wouldn't say 6 and 4. We'd number 1, 2, 3, 4, and we'd say 2-bromo 4-chloro, if anything. So that name is wrong. 3-bromo 2-chloro. Oh, yeah, 3-bromo 2-chloro toluene. Let's try that one. 3-bromo 2-chloro. So 3-chloro 2-bromo. So this is 2-chloro 3-bromo. Saying it that way is wrong. 3-bromo 2-chloro. Sorry, that makes more sense. Alphabetical order. B comes before C. So that's why the last two are wrong, right? Chloro wouldn't come before bromo in this answer, and it wouldn't come before bromo in this answer. So those are wrong just because they're not in alphabetical order. The first one was wrong. It's in the right order, but the numbering was no good. So 3-bromo 2-chloro is a correct name. It's written out the right way. The first problem, remember, the numbering was no good. And with these, we don't even need to draw them. We can see chloro does not come before bromo alphabetically. So it's 3-bromo, 2-chloro. So you can eliminate some of your answers just by seeing, what makes sense right off the bat without drawing. Which of the following is a correct IUPAC name of the following compound? Okay, let's see what our options are. Here we have two options. We have some way of naming it as a phenol. So B and C give us some kind of phenol, and A and D give us a hydroxymethyl nitrobenzene. So it's naming it as a benzene with 3 groups. Now, if you remember, with 2 groups we use orthopara. With 3 groups we find a common name like toluene, phenol, aniline, and then we name 2 substituents. So A and D are already wrong because they're not following our rule of finding a common name. So since phenol is given here, we can use phenol. Now let's look at the groups. We've got 4-methyl, 1-nitro phenol, 4-methyl, 1-nitro, 2-phenol, and 5-methyl, 2-nitrophenol. Now here's the problem with B. If you're calling it phenol, that means the OH group has been part of the parent chain, then phenol is number 1. You wouldn't say 1-nitro and then call the molecule phenol. If you're going to call it 1-nitro, then it's aniline. So B is wrong. So C is the only one correct because it follows the rule. It's naming it as a phenol, which automatically makes the OH the number 1. And then with the numbering, the nitro would be 2 and the methyl would be 5. So that is how you do that one. So we just eliminated A and D because those are not the right rules for naming. And then B and C, if you're calling it a phenol, the OH is the number 1. What organic product is formed when benzene reacts with nitric acid in the presence of concentrated sulfuric acid? Remember, these are substitution reactions. When we add nitric acid, we end up with a nitrobenzene. We add the NO2. So the answer here is D. We don't end up with sulfuric acid being added on at all. Don't confuse that with the addition of the sulfur group that we looked at also. Here, the sulfuric acid is the catalyst. Was that the last one? Yep, that was it. All right, guys, hopefully that answers some of your questions that you're having about this quiz. Good luck on the next one.